the previous lecture. Okay, now I will give you a solution for the previous assignment. Okay, and will maybe teach you a little bit. Okay, for the inductor and the capacitor combination. Okay, maybe I think 20 minutes. Okay, and after that we will talk for the next lectures. Okay, now that we will review about the review about the chapter 1 to chapter 6 again, chapter 5 again, or maybe continue to the next part. Okay, in the previous lecture,
ฮัลโหลครับอาจารย์อาจารย์หลุดหรือปะใช่ครับอาจารย์ผมไม่ได้ยินอาจารย์พูดนะครับอาจารย์หลุดไปแล้วครับ
okay. Hello, everyone can listen my voice. Can you hear me?
ได้ยินนะครับ
ได้ยินไหมเอ่ย
ได้ยินครับ
ได้ยินแล้วนะโอเคไม่หลุดนะเมื่อกี้เน็ตหลุดโอเคโอเคเห็นที่โชว์ไหมเห็นที่แชร์ไหมเอ่ย PowerPoint
เห็นครับ
เห็นนะจะได้สอนได้โอเคงั้นจะได้ไปต่อนะโอเค for the some technical problem in the previous exercise I provide you about the 3 assignment 3 quiz this for the second one that I think almost everyone already finished I give you I and in the first I give you I ask you for V you differentiate them now if I give you V EAT I ask you for I you integrate them respect to time After that, okay, after you integrate them, okay, you must substitute C0 in here, and we use the initial conditions I at time equal to minus 0.5 second equal to 1 amp, okay, equal to 1 amp, substitute them, you get the, okay, you get this constant. The general form of the I will be 20 by minus 20 by 3, E minus 3T plus about 30.9, okay, amp. Now, the key is another one's question. This question is a little bit long, okay? This question asks you for almost every topics, okay? The first one, the question is about the inductors, okay? It give you about it provide you about the current 10T E minus 100T, okay? And ask you to determine that. You can see that the function TET, okay? The way to differentiate them is not so simple, but it's not too difficult. Differentiate G and H, okay? You get G differentiate H, part H differentiate G, okay? That you already study in the calculus, okay? Give you two terms, okay? It's here, okay? After that, you multiply with the inductance, okay? And the inductance value give you here, okay? Okay. The next one, the questions ask you to determine the voltage, the inductor's voltage at the time equal to 12 milliseconds. At the time equal to 12 milliseconds. Okay. Therefore, in this, okay, at the time equal to 12 milliseconds, you substitute T equal to 12 milliseconds in here, and you get here, okay, you get, okay, V at the time equal to 12 milliseconds equal to minus 15.1 millivolt. Okay. The first question is considerably easy because you differentiate them directly. Okay. Even though this term is TEAT. Okay. Require you differentiate F, differentiate G, G differentiate F in here. The second one is considerably more tougher than the previous one. Okay. Require your integration skill. Okay. You integrate. Okay. You integrate here. Okay. Okay, integrate here is integrate EAT. Give you here. Okay, you integrate step by step. Okay, give you here. After you get T naught, you know that. Okay, the question is okay. Okay. You organize the term. Okay, simplify that. Give you here, and after that, you get here. Now, the questions provide you the initial conditions I at the time equal to 0 equal to 10. Okay, equal to 10, give you here. Okay. I at the initial condition IL0 equal to 10, substitute them similarly to the previous exercise. Okay. Now, in this case, it's asked you for I equal to 0.1, 0.1. Okay. It give you here. Next one. Wait a minute. Okay. Yeah, 0.1. Okay. That's time equal. Right. Okay. It give you, okay, at the time equal to 0.1. In this case, IL equal to about 24 amp. The third one is, okay, is more complex than the previous one, okay? In this case, the questions give you I and ask you for power. But you know that for I, you can get V, right? VL equal to L di dt, okay? Differentiate I, okay? Differentiate I give you V in this term, and I will use in this term originally, okay? Different constant give you 0. Differentiate A, EAT give you AEAT, okay? After that, you substitute them, okay? You get them in the closed form, okay? Therefore, the result will be equal to Here 60 and 1 minus E minus 40t, E40t, microamp, well, microwatt, sorry. Okay. Okay, the questions ask you that, okay, if the power at time equal to 50 milliseconds, okay, you must substitute them, okay, t equal to 50 milliseconds in the final answers, okay, in the power of the inductors here. In this case, you substitute P equal to 50 milliseconds, give you 4.5 microwatt, approximately that. Okay. Next one, if it asks you for the energies, okay, the energies will be provided by the closed form equation is here, okay. The closed form equation is the B equal to 0.5 L I square. 0.5 L I square, okay, give you here. Okay, I square give you here, okay. The questions ask you for the energy that the time equal to 40 milliseconds, okay. Remember that, okay, you substitute 40 milliseconds here, you get the unit of the energy is joule, okay. Okay, substitute them step by step. Now, okay, right, I told you before, okay, the overall question in this exercise is in this question is here. You can see that give you for V or give you I, can ask you V. You know that V L equal to L di dt. Or give you V, can ask you for I. Okay, you can see that if you know V, you can find I. If you know I, you can find V. Okay, but if you know one of them, okay, if you know I or if you know V, you can find another one. Therefore, you can find power P equal to IV. Okay, and if you integrate the power respect to time, or you can find the closed form equation, okay, you can find the energy after that. Okay, this is the overall solution in here. The last part of the inductor and the capacitor is the inductor and the capacitor combination. Okay, the inductors, okay, the way to remember the inductor combination and the capacitor combination is very, very easy. Okay, okay, I will summarize that. Okay, the inductor is the same as resistor. Everything is the same as resistor. Why? Okay, okay, if you have the inductor connect in the series, the equivalent inductor equal to the sum of them. Okay, L equivalent equal to the sum of them. Okay, the abbreviation is, okay, L equivalent equal to L1 plus L2 plus L3 plus Ln. Okay, everything is the same. And for the inductor that connect in the parallel, the inductor that connect in the parallel is the same as the resistor too. Okay, okay, okay. 1 divided by, okay, inductors, equivalent inductor equal to 1 divided by L1 plus 1 divided by L2 plus 1 divided by LT and so on. Okay, the way to combine them very easy, right? Inductor, the same as the resistor. Okay, but the capacitor is different. The capacitor is a reverse, okay? The reverse. How it reverse, okay? The capacitor in series, if the capacitor is connected in the series, you combine them like the resistor in parallel. Write the resistor in parallel. Therefore, 1 divided by C equivalent equal to 1 divided by C1 plus 1 divided by C2 plus 1 divided by Cn. Or C equivalent equal to 1 divided by 1 minus divided by C1 plus 1 divided by C2 plus 1 divided by Cn. So, okay. For the capacitor that connect in parallel, the capacitor is connect in the parallel is combined like the resistor in the series. It's a reverse. Okay, you can see that resistor, inductor is the same. Capacitor, reverse. Okay, okay, it's a reverse. Now, in order to give you understand, is here you can see that, okay, if we have this circuit structure, it maybe have some, okay, resistor, inductor, or the capacitor. We don't care. We check your circuit structure first. Okay, if it in some suitable form, you can combine them. In this case, this capacitor and this capacitor, 6 microfarad and 3 microfarad is connect in the series. Okay, if it connect in the series, it means when you combine them, okay, the formula to combine them perform like parallel. Okay, write the resistor in the parallel. Okay, and if it connect in the parallel, you can sum them. Line is connect in the series. Okay, therefore the equivalent equal to 3. Okay, 1 plus 2 equal to 3. And here the inductor is the same as the resistor. Okay, if it parallel, you combine them like the parallel case. Okay, 1 divided by L equivalent equal to 1 divided by L1 plus 1 divided by L2. Okay, yeah. And two of them, you can see that two inductor is connect in series. It connect in series. You can combine them like the resistance in series. Only add them. Okay, 0.8 and 1.2 give you 2 Henry. Remember that in some case, the networks show in this this circuit diagram contain the 3 inductor and the 3 capacitor, but there are no series or parallel combination of either inductor or the capacitor can achieve. You can see that 2 of them inductor, if it parallel with the capacitor, you cannot combine them. Okay, here inductor series with the capacitor, you cannot combine them. Okay, you cannot. Okay, it means it's not all structures of the inductor and the capacitor that you can combine. Simplifications of this network cannot be accomplished using the techniques present here. Okay, present here. Yeah. Okay. Can you see my? Can you see this question? Okay, let's do it in 10 minutes quickly. Okay. Use the capacitor. Remember that the capacitor is a reverse process. If it connect in the series, you perform like its resistor in the parallel. Okay. Capture so questions finished, and I will give you more time. Okay. If you finish them, okay, I will give you solutions soon. Okay. And after that, I will review about the midterm after that. Okay. 5, 4, 3, 2, 1. Hello? Anyone finished already? Anyone can hear me? And I will provide your solution if you finish. If you finish that, okay, you will post the solution in the meeting chat again, okay? Okay, if we can finish this fast, okay, I will, okay, I will, okay, reviews your exam for you, okay, reviews the midterm exam, not the exam, okay. Sorry for that, okay, I checked the emails from the live, from the faculties, okay, for urgent feelings that the channel for the exam that we must take the online exam by using the Microsoft Teams, okay, checking a little bit one, okay. ได้ยินกันไหมเอ่ยเงียบกริบเลยเกิดอะไรขึ้น
ได้ยินครับ
ได้ยินครับ
ไหนเช็คซิมากันจริงหรือเปล่าเนี่ย Okay, in order to check your attendance, okay, before I download the attendance checking, okay, turn on the camera first. I will checking. You are still you are. Hello. Mm-hmm. สิทธิพงษ์ใช่ไหม right ว่าแบบทักษิณใช่ไหมปฐมพงษ์ใช่ไหม
ครับ
พัชรพันธ์ใช่ไหมสะกดถูกนะ
พัชรพันธ์ครับ
พัชรพันธ์โอเคจิมมาฮัลโหล
yes sir yes
yeah พิชัยยุทธใช่ไหมชื่อพิชัยยุทธใช่ไหม
ใช่ครับครับ
อัศมาใช่ไหมคนไทยหรือเปล่าไทย
ใช่ yes
เสร็จยัง
เสร็จแล้วค่ะ
เสร็จก็ if finish okay you post your answer in the meeting chat okay I can check that and I will okay after you finish okay I will continue for the next part Okay, it's correct one. ธนยุทธชนติเสร็จยัง
ยังเลยครับ
แป๊บเดียวก็เสร็จแล้ว That right? Can I pronounce correctly? Okay, that right? Your submission is correct one. Okay, is correct. Okay, semangat. Okay, correct one. ไหนชื่อ Asika. Asika, right? Can I pronounce correctly? Asinka or Asika?
Ashika.
Asika. Okay, it's correct one. Okay, and I will, okay, wait your friend in another few minutes, okay, and I will review for the midterms. Okay, only reviews that recovers all topic that you must read for midterm.พัชรพันธ์เสร็จยัง
ส่งมาแล้วครับอาจารย์
มีเอ็กโคด้วยโอเค
อาจารย์ครับเมื่อกี้ผมหลุดนะครับเช็คชื่อให้ผมหน่อยครับ
ไม่เป็นกลัวระบบมันจะดีอย่างหนึ่งคือเพราะมันเซฟอ่ะมันจะรู้ว่าใครเข้าตอนไหนออกตอนไหนผมก็จะเซฟตอนหลังๆคือพอตอนหลังๆผมเซฟผมก็จะรู้ว่าใครเป็นไงบ้างคือคุณลองไปดาวน์โหลดดูก็ได้มันจะบอกเลยว่าอย่างเช่นสมมุติคุณเข้าตอน3 โมงออกตอน3:29แล้วเข้าใหม่ตอน3:30อย่างเงี้ยมันก็จะรู้ว่าคุณออกไปนาทีนึงเนี่ยคุณไม่ได้โดดน่าจะเป็นเน็ตหลุดหรือว่าเป็นอะไรประมาณนี้
ครับ
มันจะรีพอร์ตหมดเลยรีพอร์ตจนบางทีคนดูเนี่ยยังปวดหัวเลยแบบเฮ้ยทำไมไอ้นี่มันเข้าออก2-3 ทีอะไรเงี้ยซึ่งเข้าใจในทางปฏิบัติอ่ะมันไม่ได้นั่นหรอกแต่มันก็มีนะเด็กบางคนตั้งใจจะทริกกี้ก็มีเหมือนกันอย่างเช่นแต่ไม่มีในคลาสผมหรอกส่วนใหญ่จะมีในคลาสอื่นก็เคยเห็นเหมือนกันว่าอย่างเช่น3 โมงเข้ามานะพออาจารย์ก็เช็คชื่อตอน3:15ปั๊บนะ3:16 17อ่ะเขาก็ออกแล้วเขาไปเข้าอีกทีตอนแถวๆเกือบ4:30เลยคือประมาณว่าเข้ามาเพื่อเช็คชื่อนึกออกไหมเข้ามาต้นชั่วโมงแล้วก็เข้ามาท้ายชั่วโมงไม่ต้องกลัวเพราะว่าอย่างพวกคลาสอิงภาษาอังกฤษคลาสอะไรอย่างเงี้ยเขาเช็ค attendance เร็วเน็ตวันนี้เน็ตบ้านผมก็หลุดเหมือนกันเมื่อกี้ตอนแรกที่เข้านะมีปัญหาเหมือนกันไม่รู้ว่า
โอเคครับ
เดี๋ยวอีกสักนาที2 นาทีนะเดี๋ยวจะให้โซลูชันละทำกันไปเยอะแล้วOkay, during you take this assignment, okay, now I will pronounce some information to you first, okay. The first one is the midterm exam style, okay. The midterm exam is close similarly to the normal quiz or normal practice that we use in our class, okay. I will provide you question, okay, and you answer it to me, okay. But only one thing is different. Instead, you send the solution to the meeting chat that's difficult to see who you are and I cannot grading immediately, okay? I will order you to scan the same. You scan in the image file in here, okay, in the JPEGs, okay, and send it to me at my email, okay? What about my email? I will tell you for in the midterm exam day, okay? In the time is come, I will tell you, okay, how to write the top or the title of the paper is, okay, is you must write, okay, what about the name, the subject code, okay, about the sequence or the pattern of them, okay, for easily for grading, okay, and if you miss some information, your mark may be missed, okay. And the second one is, okay, is the midterm exam, okay, if you are you use the computers, okay, therefore you must write the answer in about maybe in the paper, something like that, okay. I think it's almost all, maybe 50% used in the paper base, okay, and you can use your smartphone to capture them and upload it to the email, okay. Or if you have the iPad and you can write in the iPad mode already, okay, you can write them and you can send them to my email immediately, the same, okay. Remember that, send to my specific email, okay. In fact, I have 3 or 4 email, but I have some email that provide for this channel and provide only that time, okay. If you send in the other time, okay, it may be classified to be the spam, okay, and maybe eliminate all, okay.ฤทธิพงษ์ใช่ไหมฤทธิพงษ์
Yes อาจารย์
ไฟล์ทำไมมันเป็นไฟล์อะไรเนี่ยมันเปิด
Yes I will
มัน
send
ไม่ได้เป็น
again
JPEG เหรอ
I will send again
จริงๆผมจะใช้ Photoshop เปิดก็ได้นะแต่มันลำบากลำบนก็เลยไม่เอาให้มันง่ายๆนี่แหละจะได้เซตเป็นง่ายๆเป็นมาตรฐานเดียวกันหมดโอเคokay I think almost all of you already do it, okay, finish. Okay, I provide you the solution. Okay, if you don't do it, try to do by yourself. But if you already do it completely, I think almost all solution is, this question is considered very simple. Okay, it's only teach you how to apply this formula. Okay, 3, you can see that the first one, 3 inductor, 3 capacitor connect in the series. You perform them like you perform in the parallel structure. And the next one, 2 of them will be connect in the parallel. If we connect in the parallel, you combine them directly. Therefore, the result equal to, okay, is equal to 12.59 about that. Okay, 12.5. Okay, 9. Okay. Next, another 3 will be combined in the series. Therefore, you combine like this parallel. Okay, and 2, the same. 1 divided by C equivalent equal to 1 divided by 7 plus 1 divided by 5. Okay, the result is about here. 2 of them will be connected in parallel. The way to combine, you combine like is series. Okay, you adding them. Okay, it's about 2.9 and 0.3 equal to about a 3.2. Okay, about that 3.17. See ya. Okay. Now, okay, I think it's okay to finish about about this inductor and the capacitor. Okay, we can cut the topic to now. Next one. Okay, we have another 30 minutes. Okay, and I can provide about the lovely, okay, about the lovely information for the midterm. Okay, review it again. How many topics you must read? Okay. Okay, I will checking for your friend first. Okay, for your assignment. Okay. 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 The midterm is conclude. Okay. The midterm is includes 5 chapter. 5 chapter. Chapter 1, chapter 2, chapter 3, chapter 4, chapter 5. Chapter 1 is only provide about the introductions idea. Only the introduction idea. Okay. Now can you see my slide? Okay. Okay. The key for the chapter 2, even though the chapter 2 is too basic, but it's very important in the unit, okay, and the definition of the important quantity that we physically compute, okay. In fact, we have about the 4 or 5 quantity that you physically are, okay. The charge. If the charge is moving, give you the current, okay. The current, you get the voltage, okay. You know the current and you know the voltage, okay, give you power, okay. Power. If you integrate power respect to time, give you energies, okay. Therefore, it have only 4 to 5 quantity that physically act for, okay. Charge, current, voltage, power, and energy. Okay. The unit that every unit that used in this course, in this textbook, is the SI unit, okay, not British unit, okay. Okay, remember that the SI unit, okay, the SI unit. Okay. Okay. The SI unit is already defined by here. You know about that. Okay. The current is amp, the voltage is volt, okay, and okay, the range is met, okay, and so on. Okay. Give you define and how to write the unit in the suitable form. Okay. It's only the basically. Okay. The next one, the provide about the definition of the charge. Okay. If the charge is moving, okay, is a charge. The unit of the charge is a coulomb. If the charge is moving, we see the current like a small particles that move. Okay, the charge is moved. If the charge is moved, give you the current. One charge move in 1 second, give you 1 volt. Okay, you know the relationship between the current. Okay, the current equal to the difference of the charge respect to time, or the time rate of change of charge. Okay, and the charge will be equal to integrate the current. Therefore, if I give you the charge, you can find the current. If I give you the current, you can find the charge too. Okay, and from the ohms, okay, next one is the voltage. Okay, you know what about how to define the voltage? Plus minus everything clearly first before you apply KCL or KVL. Okay, you know the current and you know the voltage. You can find the power P equal to IV. Okay, and the unit of the power is what? The key parameter of the power is how to differentiate the absorb or generate power. Yeah, you know that the power is absorbed when the current get in from plus terminal, and when the current get out from plus, it will be deliver or generate. Yeah, you know how to find the, in this case, it give you the current, it's ask you for the charge or so on, or some class maybe give you the charge. Okay, question maybe give you the charge and ask you for the current also. Okay, next one is about the voltage source definition. Okay, the voltage source will be defined by this circle. Okay, and the current source defined by the arrow direction and this subject circle. Two of them is the same, is independent. The independent is use the circle shape. Okay, the circle shape. And for dependent is have the diamond shape instead. And the dependent is have both the current, the dependent current source and dependent voltage source. Okay, even though the name of them is a voltage, okay, dependent voltage, but the value of them, okay, the voltage that it generates is maybe depend on the current or depend on the voltage at some point. We don't care. Okay. Okay. And the last one is provide you of Ohm's law. V equal to IR. Okay. And in this case, the resistance is the receive power or absorb the power. Therefore, if plus and minus is here, the current must be get in from plus terminal. Okay, plus terminal. Okay, it's only the first one in review that. Okay, this only review that, and you must read every topic and take the exercise by yourself. Okay, next one. Okay, next one is about the voltage and the current law. Okay, the two main law is the Kirchhoff voltage law and the Kirchhoff current law. Okay, it teaches you about, okay, how you must know how to simplify the node first. Okay, especially in the nodal analysis. Okay, you write them. If the circuit is not clear, you must simplify them first to emphasize that how many nodes you have, and for each node, how many branches connect to them before you can apply KCL correctly. Yeah, we apply the KCL. Current get in equal to current get out. Okay. The voltage is, okay, we set them in the clockwise direction. Okay. And we define the voltage across each element. Okay. If in the clockwise direction, if it means minus first, it's minus. If it means plus first, it's plus. Okay. If it means minus first, it's minus. So on. Okay. You formulate the equation until the complete every device in that loop will be finished, will be used. Okay. And the equation equal to 0. Okay. Okay. In this case, we will provide you the example of a single loop and the single node pair, a simple one. Okay. Single loop and the single node pair. The next one is okay, is about, okay, how to combine the source. Okay, we have the voltage source. If the voltage source in the series, you can combine them into a single one. What about Thanapat? What about house? What about the joking? You forgot to mute it. Okay, your routing is already in the room. Okay. Okay. We can continue the next. Okay. Okay. If you have the is must be connected in the parallel, and you can combine that. Okay. Why the current source cannot series, or why the voltage source cannot parallel? Okay. I already teach you in the provide you in the detail. Okay. Next one is about the resistance. Okay. The resistance, if we connect in the series, you can combine them by adding them, by sum them. Okay. If the resistance in the parallel, you can combine them too. Okay. And the result equal to 1 divided by R equivalent equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by Rn. Okay. Okay. And the last one is the voltage divider. Okay. The voltage divider is the situation when you have, you know about the voltage at this terminal, and you have two resistance connect to them. You would like to find V1 or you would like to find V2. Okay. You know that, okay, the way to find V1 in the term of V and in the term of R1 and R2 will be in this equation form. And the next one is the current divider is another situation when you know the total current flow in here and split into 2 or 3 or 4 branch, okay? Each branch, you know only the resistance of them. You would like to find I1 in the closed form equation of I or R1 and R2 and R3, you can get here. Okay? This for the second chapter. Okay, the second chapter is mainly on the Kirchhoff current law and the Kirchhoff voltage laws. Okay. Next one is about wait a minute. Okay, next one is about the nodal analysis and the meta analysis. Can I drink a little bit? Okay. Okay. Next one is about the nodal analysis and the meta analysis. Okay. We have the node. We can take the nodal analysis on the circuit that have only current source. You can see that only current source, no voltage. Okay, only current source. Okay, if all source in the circuit is a current source, it's easy to implement. Okay, you know that. Okay, you set one of them to be the reference node, the other to be node 1, node 2, node 3, and after that you apply KCL to each of non-reference node. Okay, you organize the equation and you can solve them. Okay. Therefore, if the circuit is considerably difficult, such as in the example, okay, I recommend you should redraw them first. A lot of the student is lazy. I can say that it's lazy to draw the circuit, to redraw the circuit, to simplify them. And the result is almost all take the long equation. Okay. Remember that if you miss only one branch in here, okay, the equation is gone, everything is gone. Okay. Now, do you solve 3 equation 3 unknown or 4 equation 4 unknown? Depend on the situation is. Okay. I already teach you how to do it. Next one, in the case that, for example, in this circuit, if the circuit almost all source is the current, but only 1 or 2 is the voltage source. Okay, you know that it cannot apply the nodal analysis directly. Okay, you must modify them. In this case, you will modify them to be the supernode. Okay, to be the supernode. Okay, the way to achieve the supernode is here. You create the bigger node across that. Okay, and you apply KCL to each of non-reference node. Okay, in this case, when you implement one supernode, one KCL equation is gone, but you will get another one auxiliary equation from the relationship of the voltage source and the nodal voltage inside that supernode. Okay, you know the systematic thinking for here. I teach you a lot for the supernode analysis. Okay, next one is for the mesh analysis. For the mesh analysis, it can apply on the circuit contain only voltage source. No current source in here. No current source. Okay, only voltage source. You apply K, the Kirchhoff voltage law in each mesh. Okay, set the equation and you can solve them. The result that you solve is the mesh current I1, I2, I3, and I4. Next one, okay. If the circuit is have, okay, you can apply the mesh analysis to solve them. Okay, in the special case, if it have some current source, it depends on the current source position. If the current source already in the parameter in the mesh that don't share for the other, is okay, in the branch that have no sharings between two mesh. Okay, you can set that the current source, the mesh current, equal to that current source immediately. Okay, the same as here, I1 and I3 can compute immediately. But in this case, in the case that, okay, if it have some, if it have some current source located between two mesh, okay, in this case is unavoidable. You must form a supermesh instead. Okay, form a supermesh. Okay, and you apply instead. You apply the KVL to simple mesh. No, you apply to that supermesh. That supermesh immediately. When you apply one supermesh, one KVL equation is gone. Okay, you require another one equation for using for solving. Okay, the unknown. In this case, okay, you can find the auxiliary equation in the branch between dash mesh. That in the term of this mesh, the mesh in the left hand, in the right hand, and the current source. Okay, you can find the super mesh already. The idea of the super mesh, even though and the super node and mesh is a simple one, but I recommend you must several times to make you fluent and understand about them. Okay. Next one is in the case that the circuit that you can comply, you can apply nodal or the mesh analysis to them. Which technique is the best for you? Okay. The technique that provide fewer equation. Okay. The lower equation is the faster in computation. Okay. Okay. Therefore, if the nodal, when you apply node, it have the fewer equation than the mesh. Therefore, you choose select, okay, the nodal analysis, okay. But in another case, if the mesh will provide the fewer equations than the nodal, you should apply the mesh instead. And the last, okay. But in the last case, if mesh and node can apply the same number of equations, okay. The next one is see the quantity that the question asks, okay. If the quantity that the question is the current, you should apply the mesh analysis, okay. But if it's like you for the voltage, you should apply the nodal analysis instead, okay. Clear? Any question before we go to the chapter 5? Okay.
No, sir.
Okay, if we don't have, we can go to the next one. Okay, every topic that I told you, you must take the exercise, read and understand it, okay, and take the exercise. A lot, okay. Next one, the useful circuit analysis technique, okay. So, oh, sorry. Wait a minute. Okay, the next one. Can you see my slide? Linearity and superposition.
No, I didn't experience.
No.
sir.
No, sir. Okay, waiting a minute. Can you see?
Yes.
Okay.
Yes, sir.
Okay. The next one is the linearity and the superposition. Okay. The linearity and the superposition frequently used in the bigger circuit, the circuit that have so many independent sources. Okay. You can see that the response, okay, the idea of the superposition is very simple, is here. You can see that we activate each source, okay. If you would like to find I in this, okay, if you would like to find I in this circuit that show in this slide, you can see that we have two sources, right? We find IX from 3-volt source first, and we find IX from 2-amp source later. After that, if we would like to know the effect from all source, okay, it will be sum the result later. Okay, very easy. The key for this step is you must turn on only one source at each time, and you kill the other source. How to kill the voltage source? You can kill by short circuit them. And the way to kill the current source, you can kill by open circuit. Yeah. Yeah. If it have some dependent source, for dependent source, we don't care for that. Okay. Then okay, the process of the independent, the linearity or the superposition is depend only on independent source, the circle shape. Okay. In this case, we have two independent source. You take them 2 times. Okay, 2 times. Okay. You turn on the first time you maybe turn on 10-volt source and you kill 3-amp source. Okay. The second time you in the reverse process you turn on 3-amp source and you turn off 10-volt source instead. Okay. Next step, okay, is teach you about the sort transform. Okay, the sort transform is mean if you have the voltage source series with the resistor. Remember that series, not parallel. Okay, if it in parallel, you cannot transform them. Okay, if you have the voltage source series with the resistor, you can change them to be the current source parallel with the resistor. And if you have the current source in the parallel with the resistor, you can convert them to be the voltage series with the resistor instead. Okay, the way to compute about the voltage and the current of that transform is can compute by the Ohm's law. Okay, next one. Okay, you can see that we can use the sort transform to simplify the circuit. Okay, reduce from 5 node to be a single mesh. Okay. Next one is next one is about a Thevenin equivalent circuit. The Thevenin equivalent circuit state that any complex network, you can simplify them by use a single voltage source series with the resistor. Okay. And in the Northern is said that the equivalence, then you can see that the complex network circuit, can replace by a single voltage source series with the resistor. Or the complex network can be replaced by a current source parallel with the resistor. Okay. The Norton as the Thevenin is the equivalent by using the Trosson form. Okay. In this class, I teach you how to determine only the Thevenin, the left-hand side. If I ask you to determine the Norton equivalent circuit, you will use the sort transform for the Thevenin in the last step. Yeah. Okay. For the Thevenin, I will briefly you. There are 3 types of the Thevenin is, that have only dependent source. It have only circle shape, independent source. Okay. The next one, it have both source, all source, circle and the diamond shape. Okay. And the last one, if in the case that you have only the diamond shape or you have only dependent source, no independent, the way to compute it differently, I provide this lecture to you so many exercise or the example, next one, next one. After we know about the Thevenin idea, the maximum power transfer theorem will be provided that take advantage from the Thevenin equivalent circuit. If you would like to find the resistance that receives the maximum power from the transmission section, you must determine the Thevenin equivalent circuit first, and after you get RS or RTS, you know that RL will receive the maximum power when it equal to RTS. Only that. The key, I think, from my point of view, the difficult task form for the maximum power is the Thevenin equivalent circuit. If you cannot find the Thevenin equivalent circuit, you cannot find RS. If you cannot find RS, you cannot determine what about the RL that receive the maximum power, because RL must equal to RS. Next step is teach you about the Y and the data connection. Y and the data connection. And you can convert them into another form. This is provide you overall point of view of all topic in the midterm. The quota for each chapters, I already provide to you. Now in the midterm, you must, or I recommend you to have those. If you write in the paper, you must have a lot of the empty paper for write your answer well. It's all. Any question?
อาจารย์ครับทศนิยมนี่มีผลกับคะแนนไหมครับอาจารย์
ก็มีไหมถ้าไม่ปัดจนน่าเกลียดก็ไม่โดนหักนิดๆหน่อยๆหรอกนะก็น่าจะให้เต็มอย่างเช่นสมมุติว่าคำตอบมันคืออย่างเช่นค่าคาปาซิเตอร์ที่ตอบกันเมื่อกี้ใช่ไหมได้เท่าไหร่นะ 3.1667 ใช่ไหมถ้าจำไม่ผิดนะคุณอาจจะสอบ 3.7 ก็ได้ไม่เป็นไรแต่ถ้าคุณตอบ4เนี่ยมันผิดไหมมันก็ไม่ผิดนะมันปัดใช่ไหมแต่มันเออร์เลอร์เยอะมันก็โดนหัก อย่างน้อยก็ตอบสักทศนิยมสัก2ตำแหน่งนะในกรณีนั้นหรือไม่งั้นคุณก็เขียนให้มันอยู่ในรูปของ engineering format นะ engineering format มันก็จะใกล้เคียงกับความเป็นความจริงใช่ไหมอย่างค่าก่อนหน้านี้มันก็จะอย่างเช่นถ้าเป็นค่าทศนิยมสมมุติ 0.654 อย่างเงี้ยคุณอาจจะเขียน 0.6 ก็พอแต่ถ้าคุณตอบเป็นหลักของตัวเลขทางด้านวิศวะมันก็จะต้องตอบเป็น654มิลลิเห็นไหมแทนที่จะเป็น 0.64 อะไรเงี้ยมันก็ต้องเป็น654มิลลิมีอะไรอีกไหมครับเงียบไปเลยโอเคไหม
ครับโอเคอาจารย์
โอเคอาจารย์
โอเคนะโอเค your friend is asking me about the resolution of your answer okay is how many number of the floating number that you must compute for example if your answer is 0.677 something like that okay yes you can use only 2 okay you may be asked answer only 0.7 okay yes it's correct but your mark may be a little bit error okay therefore it may be a reduce a little bit from the final answer, so from the full mark. Okay, but if you suitable answer in the engineering format, it usually give you a very low error rate. Okay, for example, 0.677 something like that. Okay, you know that if you answer in the engineering format, you must say that it have the 677 milli something. Okay. Okay. We see again, okay? Wait a minute. Checking the last time, okay? These subjects. I don't use smartphones unreasonably, okay? I checking is about the exam. The exam is about to confirm with you, right? I checked in the last time, the exam of the circuit is 13, right?
Yes.
Yes.
Right. 13 Jan. Okay. The time is 15 to 17, right? Right. The exam is here, right? Can you see my meeting chat? Okay. From that, okay. I check for the last update. I'm not sure if it more update than this. Okay, you can tell me. Okay, unless I cannot.
3 to 5 p.m.
ถูกไหม
3 to 5 p.m. Yeah.
ฮะ
3 to 5 p.m.
Yeah, yes, 3 to 5 p.m. The 15, yeah, right? 15 to 17 o'clock. Okay.
Yes, sir.
Okay,
Yes, sir.
firm.
That's right.
Okay, we have the. Okay, we take the exam at the time. Okay, the style of the exam. Okay, the style of the exam is I will provide the question the same that I take the quiz in the class. Clear? I will provide the question in the Microsoft team. Okay, you may be snapshot. Okay, use the print screen or something like that. Okay, save the question first. Okay, and when you answer it to me, okay, you the same that you write in the meeting chat. Okay, you maybe write in the paper. Okay, and you use smartphone to capture them in the JPEG file. Okay, but instead you return it to me in the meeting chat. No, you return it to me in email. In the email. Okay, I will at that time I will provide you the email that I use for receive your exam paper. Okay, you may have the question is why I must send why it must be email or something like that, because the email will be show you sending time, right? You must sending in the suitable time, only that time period. Okay, if you send, okay, for example, okay, you can see that the exam will finish at the 7, right? At the 7 o'clock. Okay. Okay. Also, no, 7 o'clock. 3, okay, 3 p.m. to 5 p.m., right? It finished at the 5 p.m. If you send the if you send maybe 5 p.m. and 5 minutes. Okay. Hello, can you hear me? Maybe the network interrupt a little bit.
Yes, sir. Internet connection is not good, sir.
Okay. Maybe from my way or from your way. Okay, don't worry about that. Okay. We can continue from the previous one. Okay. I use the email, right? You must send your answer to my email. Okay. Save them in the JPEG file. You may have the questions. Why is email? I will, when you send them, okay, it's not only the received time, but it will show me the sending time, right? In the case that, for example, the exam will finish at maybe in this case, the exam must finish at about 5 p.m. Yes, it's possible that you may be sent at the 5 p.m. and 5 minutes or 5 p.m. and 10 minutes at most, okay? Due to the gateway delay or something like that, okay? But if some of you send email to me at about 10 o'clock p.m., it is possible. It's nonsense, right? It not make the sense that why it's told so late like that, okay? Except you have the urgent situation or something like that, and you can show that, hey, my country is a blackout, okay? Or some urgent, okay? Case by case, clear? In the final ring, you must send me, okay, to the email. You attach the file, attach the every, okay, the slide, okay, and the solution, okay. Therefore, you must write your name, your ID at every answer sheet before you scan. And when you scan them or when you capture them, okay, you picturing them, okay, you must cover your name and your ID too to identify that, okay, that is your solution, okay. Okay, in the case that, okay, if in another case, if you already use the iPad and you can edit in the iPad or something like that, yes, it already in there, okay. Don't forget to write your name and your ID and so on in there, okay. Any question? Therefore, if you must use the paper base, okay, don't forget to prepare a lot of the paper, okay. If the paper is out, okay, you must go to your house, okay, you get off from the camera. I may be classify you as cheating, okay? You cannot get out to anywhere, okay? During the exam, clear? You must turn on the camera at all time in the exam and you cannot get out, okay? If you are not in the camera screen, I consider you are cheating or try to cheating. Clear? Is it fair? Only in the some case that, hey, you see is you forgot to get the medicine or something like that, okay? The same at the real exam as, okay? Okay, now
So,
it's all.
Azan,
Yep.
I have a question. So,
Yep.
is it allowed to write our answer on iPad?
Yes.
Okay.
If you already have the iPad, you can write the answer in the iPad, okay? But okay, depend on you, okay? And hopefully that, no, two students have the same picture of the iPad. It's impossible, right? If it have, you will cheating both. Okay. If you already have the iPad, I understand that it's difficult to extract the iPad into the paper and extract the paper to the iPad again or electronic file again. Okay, you can use either. Okay. Now it's all. Okay. Any question?
So Ashan, if we have an iPad and we are doing the question, like we are doing the exam on iPad, so can we send it on in PDF file?
No. You must convert them into JPEG.
Okay, sir. Thank
Okay.
you.
You can use the iPad, but you must convert them into the JPEG. In fact, I can open it all, okay, but I would like to make them easily for grading everyone, okay? If some is the iPad, if some is the GIF file, if some is the TIFF file, if someone is the BMP file, it's difficult to open, okay? Same all JPEG.
อาจารย์ครับผมมีคำถามครับ
มีอะไร
ผมทำในกระดาษนะครับ คือผมต้องเปลี่ยนเป็น JPEG เหมือนกันใช่ไหมครับ
ก็ถ่ายรูปไง ถ่ายรูปก็เป็น JPEG เลยไม่ใช่เหรอ
อ๋อโอเคครับโอเคครับ
ถูกไหม ถ้าเกิด if you write okay some of you is write in the paper bed right when you use the camera to capture this it's already in the JPEG file right
อ๋อโอเคครับได้ครับ
that's why I told you everyone turn in the JPEG okay I try to make them as easy as possible
เวลาส่งไปให้อาจารย์นี่คือส่งไปในอีเมลเลยเหรอครับ ใช่ครับส่งไปอีเมล
attach file okay when you send in the okay email to me okay you send in the okay you send in the attached file okay save the image as the attached file okay you use your own email okay you are maybe you are ABAC email or that okay usually you should use the ABAC email okay in order to trace who you are okay
โอเคครับ
มีอะไรไหมครับ
แล้วตอนส่งนี้อาจารย์เขียนอีเมลทาง meeting chat ใช่ไหมครับ
ไม่ใช่เดี๋ยวผมจะ I will tell you what about my email in the meeting chat in the exam
โอเคครับ
during you take the exam I will write what about my email that I prepare for you okay one last thing if you don't have any question okay happy new year and good luck for all subjects in the midterm
โอเคขอบคุณมากครับ
Thank you, sir.
You're welcome
Thank you, Ashan.
ครับ
Thank you, sir.
ครับผมโชคดีครับ You're welcome รักษาตัวดีๆนะช่วงนี้ okay save yourself from the COVID okay well I think okay the pandemic is not easy to stop okay therefore if you are infected by this even though you not die I think okay but you may be attend in the hospital a long day maybe several weeks okay and you cannot catch up okay or do you think okay you stay in the hospital you open the notebook and you can study I don't think so okay it's not practical okay good luck and may the force be with you everyone